This is a recording to go along with section 2.1 from the textbook Math in Our World. The section deals with an introduction to set theory, some basic terminology, definitions, and some symbols. So first of all, what is a set? It's a very intuitive definition. A set is a collection of objects. This can really be anything. It could be numbers, ideas, letters, really anything at all. A set it can be mathematical or not mathematical, so we really just want to deal with the more mathematical types of sets. So we say that sets need to be well defined if we're going to mathematically study them. So a set is well defined if for any given object we can objectively decide whether or not it is in the set. So for example, the set of letters in the English alphabet is a well-defined set. So we can look at any letter like C and decide that yes, that is in the English alphabet, or we could choose a letter, here's one from the Spanish alphabet, Ñ, and this one is not in the English alphabet. The set of great musicians, on the other hand, is not a well-defined set. This is a subjective type of a set. Different people would have different opinions on who should be or should not be in this set. Each object in the set is called an element or a member of the set. So for example, G is an element of the set of letters in the English alphabet, and beta is not a member of the set of letters in the English alphabet. There are three ways to describe sets, and we'll talk about these more in detail: the listing or roster method, the descriptive method, and the set builder notation. Another thing to know is that sets are often named with a capital letter, so we could talk about set A or set M, and another common one is set S, S for set. So here's the first way to describe sets, using the roster or listing method. We list elements of the set, things that are in it, between braces with commas between the elements. So here are your braces. They're like the curly brackets, right? And then we would just list things out. Elements can be listed in any order, and repeat elements are only listed once. So here's an example. Set B, this is a set that contains T, X, W, 1, and 5, and it's the exact same set if we rearrange some of those elements. So you can see the order has changed, but it's still the same set. And you'll notice the use of a capital letter to name the set, right? And then we said that set, that title of the set is equal to, and then there's the braces and the list of all of the elements. Here's a second one, set S equals, and this one is the set of three different symbols, a square, a heart, and a star. Now this is the same as if we had some repeats. So for example, if I did square, heart, heart, star, that's still the same set. We just don't usually list the elements twice. We usually just list them once. Alright, so let's practice. Write the set of months of the year that begin with the letter M. So since we're trying to write this in listing or roster notation, then to indicate a set, you start with the braces, and then you would fill in and just list out what things are in that set. So months of the year that begin with the letter M, and I suppose we should make it clear here we're talking about names in English. Okay, so that would include March and May. And it doesn't matter what order you put those two in, it's still the same set. Write the set of letters in the name Jennifer. Okay, so we have a J, an E, two N's, but we only list that once, an I, an F, we've already done E, and an R. Here are three very specific sets that you'll see over and over. So we give these special symbols just to shorten things up so that you don't have to keep listing all of the elements. So the set of counting numbers is also called the set of natural numbers, and these are just the ones that you may have learned first when you were learning how to count. So 1, 2, 3, 4, 5, 6, 7, etc., etc. And this little ellipsis indicates that there are more numbers that continue in this set. So here's the special symbol for it. It's a scripted N, right? And this is a universally recognized symbol, so it's not unique to this textbook. Any mathematician would know what this means, or any person who's studied this type of set notation before. Here are two that are not universally recognized, but for the sake of our class and our textbook, we'll understand that capital E and capital O refer to these two specific sets. All right, so E will mean the set of even natural numbers, 2, 4, 6, 8, 10, 12, etc., etc. And then O will be the set of odd natural numbers, 1, 3, 5, 7, 9, 11, etc., etc. Okay. Notice 0 is not a part of E, okay, because if you look back up at the natural numbers, this set N, 0 is not a part of that set. So 0 is even, it's just not a natural number, so that's why it's not in E. Okay, use the roster method to write the set of natural numbers less than 6. Okay, so think about the natural numbers, and then which ones are less than 6. Well, we've got 1, 2, 3, 4, and 5. Okay, and I'm still using braces and commas to indicate a set. Write the set of odd natural numbers greater than 4. Okay, so greater than means not including, so we're going to start with the next one past that, and we're looking only at odds. So 5, 7, 9, 11, and then you can't possibly list all of these. There are an infinite number. So at some point, once you've sort of, written 3 or 4 of these to make it clear which numbers you mean, you just put a comma and an ellipsis to indicate that you would just keep on listing odd natural numbers. The set of natural numbers between 6 and 13. So between means literally between. So think of 6 and 13 as kind of like the bookends for this set. And then they should not be counted as part of the set. We're only interested in the things that are between them, kind of like the books between the bookends. So that would be the numbers 7, 8, 9, 10, 11, and 12. And then finally the set of even natural numbers from 80 to 90. So from is the word that you use when you want to indicate that those numbers are a part of the set. Okay, so from is different than between. All right, so even natural numbers starting at 80 and going up to 90. So you can list these all out, or if you get a little bit lazy, don't feel like writing them, you can use an ellipsis as well to indicate that you've skipped some, and then you're ending at 90. Okay, we have a new symbol to explain that an element or an object is an element of a set, and it's this symbol here. I'll draw this a little bit bigger. It's kind of like a curved E, and this means is an element of. Okay, now you want to make sure you curve it. If you do it straight like this, it actually has a different mathematical meaning. Okay, so that's the symbol, and this is like a verb, so it means is an element of. Okay, so when you see something like this statement, this means Monday is an element of set A, and A is the set of days of the week. We have another symbol. It's the element symbol with a line through it, and this one means that the object is not an element of the set. So you may have seen something similar to this before. You've seen the equal sign, and then you may have seen the not equal to symbol. So this is sort of the same idea. All right, so if A is the set of days of the week, then March is not an element of the set of days of the week. So let's practice with this symbol, decide whether each of these statements is true or false. And I'll read these out loud, and you can see the meaning as I read them. All right, so this would read, Oregon is an element of set A, where A is the set of states west of the Mississippi River. So Oregon is a state, it is west of the Mississippi, so that is a true statement. Part B, 27 is an element of the set 1, 5, 9, 13, 17, etc. So initially you might say this is false because you don't see 27 written there, but this ... indicates that there are more elements in the set that we can't see. So we do need to check. Now you'll notice there's a pattern here. Each of these numbers is going up by 4, so I would be able to continue that, and I know that next in the set will be 21, followed by 25, 29, and so forth. And we've skipped right over 27, so I can verify that 27 is not in that set. Okay, so this little symbol means it is in the set, so that's a false statement. Part C, Z is not an element of the set VWXYZ. Well, it is in that set, so that's false. Okay, part D, zebra is an element of the set containing ZE, BR, and A, and that is false. So even though all of the letters that make up the word zebra are in the set, you never actually see the whole word itself. Okay, so the word itself is a different element than these letters. Okay, like zebra is not the same as Z or E or B, etc. And then finally, the last statement reads 3 is not an element of the set 12, 13, 14, 15. And that is true. Okay, so even though you see a 3 that's part of 13, it doesn't mean that 3 is in the set. There are 4 things in this set, and they are the numbers 12, 13, 14, 15. None of those are 3. Alright, so we have 3 ways to describe sets. We've talked about the listing method, and next is the descriptive method. So this is a verbal way of describing the set, and it uses a short statement that needs to be clear enough so that somebody can reconstruct that exact same set from your description alone. So you need to be very clear and not vague. Alright, so let's see which of these is accurate enough to describe the set 2, 3, 4. Right. So how about the set of numbers between 1 and 5? Well, it is true that 2, 3, and 4 are numbers between 1 and 5, so that sounds good, but it's not the only set of numbers between 1 and 5. So for example, I could name 2, 3. That's a set of numbers between 1 and 5. Or, well, what do we mean by numbers? What about like 1.5, 2.5, all the way up to 4.5? Okay, those are all between 1 and 5. So I haven't really specified what type of numbers, so this is not accurate enough to describe my set. Hey, if somebody just reads this description without seeing the set 2, 3, 4, they might not necessarily think of that particular set. Part B, the pattern is counting up by ones. That is a true fact. 2, 3, 4, we are counting up by ones, but it just doesn't fit the format of what we're looking for the descriptive method. So in the descriptive method, you always say, you would start out the set of, and then you describe what it is, like a set of numbers or something like that. So you usually fill this in with some sort of a noun phrase, rather than just describing the pattern. And similarly, there are many sets that count up by ones. So this description doesn't lead me to necessarily think of 2, 3, 4. Maybe somebody would think of 5, 6, 7, 8. Okay, so that one's not accurate enough. How about the pattern is counting up by ones from 2 to 4? Again, this is a true statement, and it's pretty clear what set is meant, but it just doesn't fit the technical format of the descriptive method. So it doesn't start with the set of something. All right, so I'm going to throw that one out as well. How about the set of natural numbers from 2 to 4? Okay, so I've started at 2, ended at 4, and I have specifically stated what type of numbers, the natural numbers. Okay, so I know that those are counting numbers, and the only ones from 2 to 4 are 2, 3, 4. So this is a good description for that set. And finally, the set of integers between 1 and 5. So we'll learn a little bit later, the integers are all of the counting numbers, as well as 0, and then all of the negative counting numbers, like -1, -2, etc. So this is also a correct description. How about an accurate description for the set containing red, yellow, and blue. All right, the set of primary colors. All right, that is true. If somebody said, name the set of primary colors, you would think red, yellow, blue if you knew what the primary colors were. So that is accurate. A set of colors. Okay, it is a set of colors, but this is too vague to describe only the set red, yellow, blue, so that one does not work. And then the set of colors in the flag of Romania. So red, yellow, blue are the colors of that flag, so that is a good description. All right, so you can have more than one that accurately describes the set. Use the descriptive method to describe the set B containing 2, 4, 6, 8, 10, and 12. So I'm looking for some sort of a pattern, a way to say in words why we've chosen this particular group of numbers. All right, so I would start out by saying B is the set of. All right, and then what are those numbers? So think back, we only know a few sets so far. We've talked about natural numbers, even natural numbers, and odd natural numbers. Okay, and I briefly mentioned integers. That one has a symbol as well, and it's a funny Z. Okay, that comes from the German word zählen, which means to count. So if you look at these numbers, these are all even natural numbers. So B is the set of even natural numbers, and not all of them, just some of them. So we need to say where this starts and ends. So we could say between 1 and 13, or we could even say from 2 to 12. All right, the next set, this one has negatives, so this can't be any of the counting number sets. So the only other one is this new one, the set of integers, and these are all integers. Okay, so this set doesn't have a capital letter name, so I just start right in and say that this is the set of integers. And again, we need to specify which ones. It's not all of the integers. So I could say the set of integers, and I'll use between this time. Okay, so think about the bookends for this set. The set of integers between -3 and 7. And you could also say from -2 to 6. Alright, so we've talked about listing elements in a set, describing using a phrase or sentence, and there's a third one, set builder notation. And this one is a more symbolic way to describe sets. It's mostly used if you're trying to describe something that would be too long to list, or if you want to really emphasize some of the different properties that the things in the set have. Alright, so this one's a little weird, but here's an example. The set containing 1, 2, 3, 4, 5, and 6 can also be described like this. This one on the right is set builder notation. So we start with braces to indicate a set, and then we have what's called a dummy variable. You've seen x used before in algebra, and x just represents any of the elements in the set. So that's why we don't specify which one. We want to refer to all of them. So what we're saying is that this is the set of all of the numbers, which we'll call x, that have, and we read this little vertical bar as such that, or we can say everything that comes after it, it describes the properties that x has. Okay? So this is the set of all of the x's such that x is an element of the natural numbers. Okay, and I could have just written that out in words, but in this notation we try to make it as short and symbolic as possible. Okay? And, so you can do and or a comma, x is, and then notice that these numbers are all less than 7. Okay, so I would finish this off and say x is less than 7. Alright, so one more time, this is the set of, you would read this, the set of all numbers, or the set of all x's that have these two properties. Okay, anything that is a natural number and less than 7 is in this set. Alright, let's try a few more examples. The set R contains the elements 2, 4, and 6. So this one has a name of the set. So I'll write R equals. And then set builder notation has braces. Okay, and this is the set of all elements X such that, and then I need to describe using symbols what are the properties or the patterns that accurately describe 2, 4, and 6. So we usually have a few of these. First of all, we need to specify what type of numbers these are. And if you think back to the ones you've learned so far, we've got natural numbers, even natural numbers, odd natural numbers, and integers. And these are even natural numbers. So I can say that in symbols. Okay, anything in this set, anything that I'm naming an X, is an element of the even natural numbers. Okay. And then I need to specify where we start and end. So I've given the first 3 natural numbers, so I just need to say that these stop after 6. I don't go on to 8, 10, 12, etc. Right, so I can say that these are less than 7, or you could even say less than 8. Let's try the next one. The set W contains the elements red, yellow, and blue. So W is the name of the set. Okay, and W equals the set of all X such that, and then how do I describe these elements? So X is, we saw 2 ways to describe these. One of them was the primary colors. So I could say X is a primary color. And notice this description is almost as long as just listing out the elements. But again, if you had a really long list of elements or colors here, maybe this symbolic notation would be shorter in certain situations. And let's try one more example. The set K contains the elements 10, 12, 14, 16, 18. So K equals the set of all X such that, all right, what type of number are these? Okay, they're even natural numbers again. So X is an element of E. Okay, and this time we have a group of even natural numbers sort of in the middle of the set. So I do need to say where it starts and where it ends. Okay, so first of all, notice that these are all the ones that are bigger than 8. And we're stopping at 18, so these are all the ones that are smaller than 20. Okay, you can say it like that, or you can also sandwich it and say 8 is less than X is less than 20, if you remember how to write inequalities like that. Alright, so all together, let's review the 3 different methods. Here's the set S containing 32, 33, 34, 35, etc. Using the roster method, this is pretty much done. This is how the set's given. So the only thing we need to do differently is include those braces. And then we certainly don't want to list all of these. It looks like the pattern continues. We just keep going up by ones. Okay, so we end with the ellipsis to indicate that there are more elements in that set. The descriptive method, right? So I want to be very clear. I don't want to be vague, and we always start by saying the set of, and then try to describe the things in the set. Okay, so first of all, what type of numbers are these? These are natural numbers. So we say the set of natural numbers. Right? And they continue forever after 35, but they start at 32. So I just want to say the set of natural numbers greater than 31. And then finally, set builder notation. So we say the set of all X such that, and then I need to just say in symbols what I said in words. So I know these are natural numbers. They're all elements of n, all elements of the natural numbers, and they're greater than 31. All right. Writing a set using an ellipsis. We've done some examples, so just a few more. Using the roster method, write a set containing all even natural numbers between 99 and 201. So think of these as the bookends. 99 and 201. We don't want to count those as part of the set. Okay, so what are the even natural numbers between them? Well, we've got 100 is the first one, and then it just continues on, and we stop at 200. Okay, so using the roster method, this would be the braces, and we would list a few to establish a pattern so that people can see we're counting up by twos when they look at this description. And then at some point you stop, use the ellipsis, another comma, and then put the ending number, so stop at 200. Using the roster method, write the set of all letters of the English alphabet. So we start by listing a few, A, B, C, and then once you get the idea, you can use the ellipsis and then state that it ends at C. Alright, so that's the last example. Quite a few new vocabulary words and symbols in here, so maybe make yourself a list. All of these are in the textbook, and they do give you a summary of the new concepts and words, so you may want to take a look at that. Try some of the practice problems in this section if you need more examples.